Hello everyone, welcome back to the channel. In this video we are going to deploy a Node.js microservice application on Kubernetes completely locally using Docker Desktop. We will be using MongoDB as our database, RabbitMQ for inter-service communication, and deploy everything using the Kubernetes manifest. By the end of this video, you will understand how microservices communicate, how to deploy them on Kubernetes, how to expose API using Ingress, and how to scale services locally. Here I have created a Node.js project. So in this I have 3 Node.js microservices. The first one is user service. In the user service I am using Express.js, Mongoose, and here I am connecting with the DB, MongoDB. I have set the schema for the user service as name and email. It has 3 endpoints. The first one is to the get call to fetching all the users. Second one is a post call to adding a user into database, and the last one is to deleting all the users from the database. This is listening on port number 3001. Another one is task service. Here the user can create a task, right? So for this I am using this task service. In task service I am using Express.js, Mongoose, and I am using RabbitMQ. For this we have a package mqblib. We'll make a connection to the MongoDB. Here I have set the schema for this. It will have title, description, user ID, like which user has created this task, and the created at like the this date format. Also I am making a connection with RabbitMQ. Whenever this app gets started, here we are making the connection with the RabbitMQ. It will retry 5 times if it doesn't connect in first go. And this is a code of making connection with RabbitMQ. So what RabbitMQ is exactly? So it is a message broker. Let's suppose a user has created a task and I want to send some notification to the user. You have created this task, so it will just communicate with another service, which is our notification service. I will talk about this later. Here in this task service we have get call to fetching all the tasks. We have post call to creating a task, and similarly we have a delete call to deleting all the tasks. Notification service, we are using RabbitMQ package. Here this will be listening to the same task queue where task is pushing message whenever it create a message. Like here it is creating a message and it is sending it to queue. Here this will listen for it event. It will just consume it, and whatever we want to do, like here I'm just logging the message. Here I'm only logging the message, I'm not sending any email to user. And also we need to acknowledge, like this message is already received by the receiver. See, we have a Docker file to creating the image, Docker image for different services. Now I have pushed this code to my GitHub repository. Here I have written all the instructions, like how to run this code, how to set up it in your local. First of all, you need to just clone this repository to in your local. Then okay, we'll go to the Docker, like how to deploy these microservices to Docker. So for this you should have Docker desktop installed in your local. In Docker desktop, to enabling the Kubernetes cluster, you first needs to go into settings. Here needs to go to Kubernetes option. You need to enable this Kubernetes option. Here in the type of cluster, choose cluster provisioning method. We'll selecting kind. Here we'll be selecting a node equals to 3, and then we'll apply. It will install the Kubernetes cluster in your Docker desktop application. It will take some time. Now this Kubernetes setup is ready, cluster is ready, and if we'll go back to the home and we'll click on the Kubernetes, here you can see the cluster is ready. It has 3 nodes, right? One is the control plane, the other 2 are the worker nodes. Now we will deploy our application to this Kubernetes cluster. For this, first we need to create the image for this Docker, right? So here in this document I have mentioned like how to build the image. You need to run this command, docker build -t, and whatever is your repository name that you can like docker text, docker hub repository name you need to add here. Like I have my docker repository name here, Victorious Weapon, and here you need to first build the images for all these 3 services, 3 microservices, and you need to push these images to your hub, okay, docker hub account, your repo. So here I have pushed the three images here, right? Now to deploying to Kubernetes, we need to first go to our command prompt. So to deploying these MongoDB RabbitMQ and services to Kubernetes, we need to run these commands. We'll simply copy this command one by one, and in our terminal, from our terminal, we should have Docker access, so you can see whether you have access or not. Here you need to apply the command kubectl apply. This deployment is created, and if you check into the Docker, here you can see MongoDB is in progress, 0 ports. Currently the port is processing, so once this pod will created, it will show one by one. Second, we will create the service for this. Here also we will go one by one, like what is in the Kubernetes file. So here inside the K8's Kubernetes folder, I have created all the files. If you check for the MongoDB deployment, here is the file. Here the kind is deployment. Replica is only one replica will be created for this. This is the match label MongoDB by which it will be find searching for the service. Service will search for this port deployment, and it has 2701 the port number where it will be exposed. Mongo service, here we'll be adding the same name as we have. Here is the name, metadata name, service name should be matching with the Mongo name where we are making the connection with MongoDB. If you check here, it should match with this name, Mongo. Okay. Next is RabbitMQ. We have config map here. This is the guest the username and password to log in into the RabbitMQ dashboard to check if any notification came, any message, any queue you want to check on RabbitMQ dashboard. This is the service. It will be listening on this port. Stateful set. Here we have defined for this. This is the task service deployment. We will creating 3 replicas and it is running on 3001, and the image it will pick from this whatever where we pushed the image in your Docker Hub repo. Similarly for task service, it will be pointing to the deployment. Okay, user service, similarly we have 3 ports, and as it will fetch from this image, it will be running 3001 port, and it is service where it will be exposing the port. We have added the type as cluster IP, so this can be accessed only within the cluster. It cannot be accessed outside of the cluster. Similarly for notification, we have deployment service. It will be getting image from our repo, and it will be listening for 3003 port, and this is the SVC file. I have explained all the files in high level. Now I will deploy the files one by one here. So I have already this deployment is already created for MongoDB. We will follow this guide. Now we will create the service, MongoDB service. Service is created. Next we will running the RabbitMQ. First we will run the config map. It is created. If we check here whether these are getting added or not, you can see this MongoDB is created here. Here MongoDB is created. If I check for and config map for RabbitMQ is also created. Next is stateful set. We'll copy it, created. Next is service for RabbitMQ. This is also created. Next is now our microservices. First we'll deploy the user microservice, so we'll create first deployment. This is created. User service, this is also created. Task deployment created. Task service SVC file, this is also created. Notification deployment, this is also created, and this is also created. Now before running the Ingress, we first needs to add create the Ingress controller. So we'll be running this command. It will create the Ingress controller, and in last we need to deploy the Ingress. See here, you can see by the time MongoDB is created, all the deployments are already created. Services are also created, all are running, and this is also created. Ingress is not created. Now you can see Ingress is also created, and if I check here, see Ingress is showing here, right? Next we'll follow the same document that I have created. We'll first check all the nodes. I will clear these logs here. See all the nodes are created. Like for MongoDB there is one node. For notification there are 3 nodes are there, all are running. For RabbitMQ there is one node. For task service there are 3 nodes, and for user service there are 3 nodes, and all are running. Next is services we will check. So all the services are up and running, and all are of cluster IP type, so these can be accessed only within the cluster, Kubernetes cluster. Next, I will check Kubernetes deployments. It has three. It has three deployments. One is for MongoDB, another one is for notification service, task service, and user service, and desired replicas are already running. Okay, and we'll check for Ingress. Ingress is also running. I will check Ingress controller. This is also running, and these are the commands to checking the logs of different entities, like for any pod, any service, or any deployment. If you want to check the logs, you can run these commands. Okay, there is a port forwarding. If you want to access any API out of the cluster, you can just do this port forwarding command. You can run and you can access the API easily. But for now we will be accessing our APIs only with the Ingress. Currently the Ingress is running on localhost. So if I check with the command this, right here I have a postman. In postman I can check whether our different APIs are running or not. Here is the get API for user service. I will try to fetch, so it is getting empty array, so there is no record created. I will try to create a user using this, so it is created. And if I now try to run this get command again, it should return the created user. Here it is creating. If I want to create a next user, Aman, and if I click, it will create, and if I check into get user, it will fetch both the records. So APIs are working fine. Next is task microservice. If I check for task, currently it is getting empty, so there is no task created. If I try to create a task for any user, let's suppose I'm trying to create for Aman, I will copy his email, user ID, and the title is task 1, description is this is task 1. If I try to create it, it has created, right? And whenever a task is created, it should create a notification. So we should check whether our notification service working or not. So we'll check the logs for notification service. I will check for this notification, kubectl logs. Here is no log available. If I listen for another service, kubectl logs, here you can see first one is the message, right? And this is received notification for a new task, task 1, assigned to user ID. So our notification service is also working perfectly, means it is getting notified whenever one task is created, and the RabbitMQ is pushing notification to that. Now we will try to access our RabbitMQ dashboard. So currently it is not accessing. So to access it, we will expose the port. So there is a command to exposing a port to outer of the. So if I run kubectl get svs kubectl svc services, and RabbitMQ is here. This is service name. If I try to copy this and svc slash RabbitMQ from port number so port is forwarding now. Event now I'm try to access. I'm able to so to log in here we have the username like guest and and I can access this dashboard. Right now if I try to create a task again with task 2 and task 2 and I try to create, here you can see a spike in this queues. Task create here, see at 8:42, right, 8:42 30 8:42 this time this got created, and I think this got notified also. See, queue is empty, and if I check for logs again, I will close this forwarding, and I will check the logs for this notification service again. This time I think the another pod has listened, so I will check for the first pod. Here, see, this time this pod has listened for the task 2, right? So our notification service is also working fine. Okay, so this is all in this demo, and before leaving the project I think we need to remove the resources. So we have like these many resources are being used, we have to free these up. We will first delete all these deployments or whatever we have, we will delete all. So if you check here, all deployments are gone, right? Pods will also go away in some time, and also we need to free up this Ingress controller. And Ingress controller is also gone, and also these ports are also free up now. Okay, and we have 3 nodes again available to serve any request, any deployment. Okay, and if you want to clear the cluster, you can just stop it again, and next time whenever you want to create it again, you can create cluster again in the same way we did earlier. Okay, so this is all in this demo. Thanks for watching, and see you in the next one. Thank you.